Okay, today we're going to start our curriculum all over again. I've told my students already that I am going to start with the very, very basics because I have no idea where anybody is in their education. It could be that these particular things are the things that you missed out on, the very basics. So I would encourage you, even if you think you know these things, to work through the worksheets. They're going to be relatively simple today, but I want you to work through those so that you have an idea about what's going on. Okay, so what we're going to do is start out with types of numbers, the types of numbers that we use in mathematics. And so they are, you will receive a chart, or you have already in your email. I apologize, I've got to go turn the heater down. I'm back. Okay, so the very first part of, if you'll remember the numbers, the very first part is like when you were 1 or 2 and you were counting blocks on the floor before you could even walk, you're counting 1, 2, 3. So those are the first numbers that you're ever introduced to. And so what we're going to do is call those natural numbers. Here's the natural. Now if you want to make notes, you can, but you will be receiving this. Mm-hmm. And this is the diagram for the numbers that I'm going to talk to you about. So natural numbers, I remember that because it's natural for a young person to start with 1, 2, 3, and so on. Okay, some people call these counting numbers. Now, as you got older, your mom taught you sometimes when you're counting cookies that there might be no cookies. So you learn the value of 0, and these are your whole numbers. Whole numbers. And the reason that I drew the circle around the natural numbers is because whole numbers include all of the natural numbers and 0. Okay, so as we get older, we learn what 0 is and add that to what we already knew. Now we know the whole numbers. And then you reach probably late elementary. Oh, my circles are beautiful this morning. Then late elementary, early junior high, you learn that not only are there numbers 1, 2, 3, and so on, and 0, but also there are negative numbers. And so all of this plus the negative numbers are called integers. Now, get yourself familiar with integers. It seems like the word integers comes up more often when in different types of problems. Okay, I apologize about the artwork. That's nasty. Okay, so integers include all the natural numbers, 0, and negatives. So we add negatives. This is an and, negative numbers. Okay, now what I want you to be sure of, that integers are, let me get a different color here, not, oh, that one won't work. Not fractions or decimals. Oh, I'm glad your little chart is going to be prettier than this. Okay. Integers include the natural numbers, 0, and all the negative numbers, but no fractions, no decimals. Okay, and integers are the most common that you'll be using as integers, although you're not going to get away from fractions. Okay, and all of these, I'm trying to find out where, okay. And all of these, are rational numbers. And then there's another batch called irrational. Now, for a while, these were the hardest ones for me to figure out, the difference between rational and irrational. When you get to rational numbers, this is where you add the fractions and then you have decimals. So it's all of these, and then we add and decimals and fractions. The same thing is true here for irrational. So now we've got to talk about the difference between rational and irrational. And this is where you need to use your calculator. Now, those of you that don't have a calculator, I have them in the classroom. Of course, that doesn't help you when you're working at home. I would encourage you to get a calculator like we're going to use on the test. Okay. If you need a picture of the calculator, I think I have one. I think Brandy, did you take one? You took a picture?
Oh, yes. Yes, I did.
Of the calculator.
Yes.
Later on, if you'd make a note, just shoot me that picture. So if anybody else needs it, I can send it to them.
Okay.
Do you mind?
No, I don't mind.
Okay. Okay, let's do that. Now, what I'm going to tell you is how to figure the difference between irrational. You're going to find out that things are backwards, so it'll be really weird for me. The difference between rational and irrational numbers is by using your calculator, okay? Now, what you're going to do is when you put the number in your calculator, let me see if I can get some. Let's do this. I'm going to finish this chart and then I'm going to erase it so that I can put some information about rational and irrational, okay? So all of these numbers, everything that we have studied right here are called real numbers. Everything here is real numbers, okay? Do you get the idea of how they're in categories and we just added a little bit more each time? Do you get the idea? Yes. Just shake your head or whatever. Yes. Okay. Now, believe it or not, there is another category that I don't know that we'll even talk about, but you need to know. There's another category that are not real numbers, and these are called, surprise, surprise, believe it or not, there's another category. If these are real numbers, we actually have a category of numbers called imaginary numbers. Okay, this is for your information only. We probably will not hit imaginary numbers. I don't think there's a need for that unless you decide to move on in college, then you'll know about imaginary numbers. Okay, if anybody needs to take a picture of this, you need to write anything down, let me know because I'm getting ready to erase. so I can talk to you about rational and irrational numbers.
Oh, God.
Okay, 3, 2, 1. Speak now or forever hold your
Hold your
peace.
peace.
Okay. Okay, rational and irrational, and we're going to practice a few of them. I had such a hard time with these, and then I finally figured out, if you'll use your calculator, and when you, oh dear, I'm gonna have to get some more markers. I hope you can see that. Okay, you're gonna use your calculator. Now, when you put your number into the calculator and it either stops, the decimal stops, the decimal that you get will either stop like 3.5 or 2.13, and that's it. Then it's rational, or if it repeats in a pattern. For instance, 2.34343434, that would be a rational number. Okay, if it repeats in a pattern, if the decimal stops, or if it repeats in a pattern, then it's a rational number. All others are irrational. So what we're going to do is try some examples here real quick. I think the colors are going to be boring today because that's about all that's working. So, okay, let's try this. Those of you that have calculators, let's try 1/5. Okay, put 1/5 into your calculator. How many of you have calculators? I may be wasting my time. Okay, only one right now. Okay, so Sherry, you're going to help us. If you put 1/5 into the calculator, what do you get as a decimal?
1.5.
You have 0.2,
0.2.
and there's nothing else, right?
That's all.
That's all. So would 1/5, would that be rational or irrational?
Rational.
Rational. Okay, and any of you others can answer what the decimal is. So rational number is like 1/5. Okay, let's look at, how about 1/3? What does it come out, Sherry?
0.3333 and keeps
And the
on
line
going.
above the 3 means that continues on with 3s. So this repeats in a pattern, right?
Yes.
And if it repeats in a pattern, guess what? It is rational because it repeats in a pattern. Y'all see? Let's do one that's irrational. How about this one? This is a special number in mathematics called pi. And on the calculator that we use for the test, there is actually a button on there that says pi. So you can just push it and push equals. And it will give you 3.141.
59624.
Okay, wait a minute. 1.141.
592654.
Okay, and it will go on. Pi goes on and on and on and on and on indefinitely. But if you notice, it doesn't have any kind of pattern at all. Do y'all see it? Since it does not have a pattern, then it's irrational. So pi is irrational. Are y'all getting the idea here? And one more. Y'all speak up if not. Let's do something like square root of 8. Sherry?
I gotta find my square root
Oh,
on my
You-
calculator.
okay. Use your green button and then go straight down from that where the x squared is and push that button. And then put
Okay.
8 and equal.
Okay. It is 2.82, 84, 27, 125.
So what do y'all think here? Rational or irrational?
Irrational.
What'd you say, Simon?
Irrational.
Irrational. It's irrational because there is no pattern and it doesn't stop. So it has to be irrational. Do you guys get the idea here for rational
Doesn't stop.
and irrational? Okay. So in your printouts that I sent to you last night in email, you'll have this chart. Okay, and it will help you. The only thing that's not on this chart is all of everything that is on here. All of these are real numbers. Okay, I don't know why it didn't get on here, but everything here is real numbers. We didn't put imaginary numbers on this chart. So you'll have one of those for your binder. I would highly suggest that you get a binder and dividers now so you won't have to start filing stuff too late where you have a big old pile of stuff. We'll do all of our lessons in sections and I'll tell you what those sections are as we go. Okay, now what we're going to do is talk about place values. Place values. That means that if I have a decimal number and I have a place here and a place here and a place here, a place here, a place here, a place here, and so on, both ways, then this is called the ones. This is the ones place. This is the tens. This one is the hundreds. And so on. Now, where people get mixed up is after the decimal. This doesn't start the ones again. The first place that's after the decimal.
Hundreds.
I'm sorry. I thought I heard somebody say something. Tenths. The next one is the hundredths. And then the thousandths. Now it's important for you to learn these, especially this far, because later on in your problems, they will ask you to round to the nearest hundredths or the nearest tenths or the nearest ones place. So what you're going to do is have two worksheets like this, and it's going to ask you, here we go. It's going to ask you to take 25.076 and put them in the correct place. Now, again, I told you most of these worksheets are going to be relatively easy, but by working this worksheet and filling it out, you're going to make yourself familiar with these and it will start to connect things in your brain. Okay, so I would definitely do these. Let's do the first one. The first one says 25 .076, I think. Let me look again. Oh, yes. Okay, and they said they want you to put it in the correct spots. And they have boxes for you to put the numbers in. The easiest thing is, look where the decimal is. So the 5 is going to go in the ones place, and you might say that to yourself. 5 is in the ones place, 2 is in the tens place, 0 is the tenths, hundredths, thousandths. So when you read this, you're going to say 25 and you read this all the way through 76, and then you read the word that goes with the very last number. So 25 and 76 thousandths. Y'all see? Okay. And these two sheets, there's two sheets that you really should fill out. Both of them. Let me get them up here. There's another one. And here's one. Please, as you fill those out, read them to yourself. 25 and 76, and use the word that's in the last place, thousandths. This would be read as 25 and 7 hundredths. Everybody good? Okay, if there are no questions, I'm going to move quickly through these so that you can practice on the sheets of paper. And then if the questions come up, let me know. We'll talk about rounding later. I want you to get used to the place of values, especially the ones after the decimal. Very important. Any questions?
No.
We're going to move on through several basics today. Next, I have found out that it was very important for me to speak about odd and even, because some students miss that. I found that out over the last year and a half. Odd and even numbers. Even numbers will always divide by 2. Even numbers will always divide by 2. There is another hint here, and it says odd numbers will always end in 1, 3, 5, 7, or 9. Okay, and the sheet that you have, I actually sent you a chart. Some of these look very childish, but I think they're just fun. You will have a chart again that have all the even and odd numbers. Okay, the odd numbers are the ones that are colored. They have the gray over them. The even numbers are the other ones. Okay, now what I would suggest, I sent you 2 practice pages. You're just supposed to tell whether it's odd or even. Okay. And then here you'll circle all your odd ones and circle all your even ones just to practice. Okay. Very short practice. I would encourage you, as you do these 2 pages, to make sure that you don't look at the chart at first. Okay. And check for odd and even. See if you can do that on your own without any help. Any questions on odd and even? We just need to get these basics out of the way.
Mm-mm.
Anybody?
No, ma'am.
Other definitions are going to be the difference between prime and composite. Now, this one, a lot of people missed in their early education. The difference between prime and composite. Now, the cool thing about this is if you learn the definition of prime, composite is everything else. Okay, a prime number. A prime number is a number that will, that's a W, will only divide by 1 and itself. Okay, a prime number is a number that will only divide by 1 and itself. Examples being 5. Because if you divided that, if you were going to find out all the numbers that would divide into 5, it would be 5 and 1. It doesn't divide by anything else. Same with 2, same with 13, and so on, okay? Any number that will only divide by 1 in itself are called prime. We will use primes later when we're doing factor trees and prime factorizations. So you need to know the difference between prime and composite, another basic, okay? Every other number. Here's examples of a composite, 12. Because yes, it will divide by 12, it will divide by 1, but it will also divide by 3, it'll divide by 4, it'll divide by 2, it'll divide by 6. Do y'all understand? If it will divide by more than just its 1 and itself, then it's a composite. Okay, 12, 15, 5, 3, 1, 15, it's composite. But 17 is prime because it will only divide by 1 in itself. Are we good? And so I gave you, yes, I gave you 2 worksheets. You're supposed to pick out the prime numbers, circle the composite numbers, very easy stuff, but it's good to get your brain to start working on the basics. You need to decide here whether it's prime or composite. Now, like 530, we don't know for sure. What about 87? Those are big ones, and they're not on the chart. I sent you a prime number chart. Again, use this as reference after you try the worksheets. This goes to 100, and it tells you the prime numbers. They're highlighted in green, okay, or gray, however you print it out. Again, our little Disney characters. Now, I sent you this. It's called the divisibility rules, okay? Now, the reason that I'm bringing this up now is because of this worksheet. See right here, we go 530. 530. Is that prime or not? Because there are some large prime numbers. Is 41 prime? I don't know. That'd be on the list, but 293 is not. So let's go through the divisibility rules right now, and you can use those to decide if these will divide by something besides 1 in itself. So here are the divisibility rules real quick. They're kind of neat to, you don't have to memorize them, but the more you're familiar with them, the easier your division is going to be, especially when we get to prime factorization again. Okay, let's do this. So I'm going to tell you how to tell if a number will divide. This is all on your sheet, so you don't have to take notes if you don't want to. if it will divide by 2, if the number will divide by 2, it ends in an even number. Okay, if it will divide by 2, it ends in an even number. So let me see if I can juggle stuff here. So tell me, if I can find a number on here that'll divide by anything besides 1 in itself, then it's not prime. Okay, so let's look at the 530. Oh, gee, that's a big one. But can you see that it will divide by 2 because it ends in 0? And that's, it could be called an even number, okay? It'll divide by 2. So if it will, then it's already composite, already. Look down here at 87. It won't divide by 2, will it? But we're not sure. That doesn't necessarily make it prime. Let's see if it'll divide by something else. If a number will divide by 3, you can add the digits. Add the digits. Now, when you add those digits, if it will divide by 3, then your big O number will divide by 3. Let me explain. Let's look at 87. Okay, 87. If I add the digits 8 and 7, that gives me 15, right? Will 15 divide by 3? Does 15 divide by 3?
Yeah.
Then 87 will definitely divide by 3. Y'all see? Add the digits. So let's look down here. So if it'll divide by 3, it's already not prime because it'll divide by something besides 87 and 1. Let's look at this one. 2 plus 9 is 11, plus 3 is 14. Will 14 divide by 3? No. So this will not divide by 3. You see? But it could divide by something else. So let's move on. 4. If something will divide by 4, look at the last 2 digits of the number. Look at the last 2 digits of the number. If they will divide by 4, then the whole number will divide by 4. Let's look at, if I can find one for you. There is not one here. Let's look over here. I'll give you an example. Let's look at, an example would be 116. Okay, if I had the number 116, I look at the last 2 digits, and if they'll divide by 4, then the entire number will divide by 4. Y'all see? Now, you don't have to be able to call all these to memory in the next 5 minutes. It's something you get used to, but you will have the divisibility rules in your binder to look back at and practice. 5 is really easy. Any number that ends in 5 or 0 will divide by 5. Any number that ends in 5 or 0, we know it will divide by 5. 6. We're not going to go on forever. 6. If the number divides by 2 and 3, if it follows this rule and this rule, then it will divide by 6 also. Everybody good? The next one. If it will divide by 10, it ends in 0. Okay. Now, you can try all of these. And if you still didn't find anything that will divide by, try, I think it's 7, 11, and 13. Yeah. Just try 7, 11, and 13. If it won't divide by any of these or those, there's a very, very good chance that it's prime. If it doesn't hit any of these rules and 7, 11, and 13 won't divide into it, then it's definitely prime. I'm pretty sure. For what you guys need. So you will have this list that I just wrote on the board, divisibility rules, and you can put that in the front of your binder so that you'll have something to look at along with your prime numbers and your evens and odds. Any questions? Divisibility, use your divisibility rules to figure out prime and composite. Again, it's not a really hard worksheet, but the more you go ahead and write, even though it's easy, it'll start to click in your brain when you need it most, okay?
Miss Deborah,
Yes.
on that chart, you said the ones that are shaded gray, they're the prime numbers, right?
Yes.
Okay.
Yes, ma'am. Prime number chart. So 2, 3, 5, 7, 11, 13, 17, blah, 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 blah. Yes, those are all prime numbers all the way to 100.
Okay, thank you.
Okay. Okay, the last thing we're going to talk about is the number line. And this will be good for you to call into memory when we talk about negative numbers, when we talk about addition and subtraction. One of the things that students struggle with a lot is adding and subtracting, multiplying and dividing negatives and positives. Now, we're not going to do that today, but we are going to give you a visual so that you can start to see the addition and the subtraction of negatives and positives. So here we go. A number line is one-dimensional. It goes indefinitely. That's why it has arrows on the end. It goes on forever and ever in both opposite directions. Right now, I am going to make the center be 0. And everything as we go to the right, as we move to the right, we're going in a positive direction. Or add. You're going to use this in a minute. You go in a positive direction if you're going to add. If you move to the left on the number line, we begin to move in a negative direction. And we're going to use this to subtract on some of the sheets that I gave you for today. Okay, now on a number line, the normal numbers, if we have 1, 0, then everything to the right of the 0 are positive numbers. 1, 2, 3, 4, 5, and so on. Moving to the left of the 0 are negative numbers. -1, -2, -3, -4, and so on. Okay, so this is a normal number line. Any questions here? This is basic. And then the last thing that I left worksheets for you are how to add and subtract, or how to add negatives. So Let's do a number line here. I'm going to leave that one up there so that we can refer back if we need to and get one that's not squeaky. Okay, you're going to have some problems like this. 3 plus 4, and then they're going to give you a box to give the answer. Well, of course, we know that's 7. Everybody knows that's 7. But what I want you to do is visually or actually write on a number line. The way you do this is you start at 3. So 1, 2, 3. This is where I'm going to start. I'm going to start there. Now the add tells me that I'm going to go in a positive direction. So I'm going to move to the right 4 places. So I'm going to go 1, 2, 3, 4. Now the place that I end up, this was 1, 2, 3, 4, 6, 7. The place that I end up is going to be the answer. Yes, this is going to be extremely elementary, but it's also going to be very useful for you when we talk about negatives. Okay, do you see how this works? You start at the first number and you begin your loops until you've done 1 loop, 2, 3, and 4. The number that you end up on is the answer. So how about if we jump right into some negatives then? Okay, let's say negative 3 plus 4. So now here's negative 1, negative 2, negative 3, negative 4, negative 5. Okay, so we start at negative 3. We're going to start right here at negative 3. Plus tells us to go in a positive direction to the right 4 places. 1, 2, 3, 4. So your answer here is a positive 1. Now there are going to be rules that we can memorize for adding and subtracting negatives, but I want you to get in your head what's happening on the number line. If you can start to plant that number line in your brain, the numbers are going to be easier. Okay, let's do this one. How about if I change this very, very little and I make this a minus? Now you're going to find out all the way through my curriculum that a minus and a negative mimic each other. In this case, we're going to start at the negative 3, but this tells us we're going to go to the left. Do y'all see? So I'm going to the left of negative 3 4 places. So here's my negative 3, 1, 2, 3, 4. This is negative 6 there and negative 7 there. And so negative 3 minus 4 is going to be a negative 7. Y'all see how this works? Very elementary, yes. But sometimes the basics are the most important thing that you're going to put in your brain. Let's do another one. Okay. Tell me what to do. Let's see. Mary, tell me what to do here. Oh, wait. Is Mary here? There you are. There you are. Okay. I want you to, I better get back.
Okay.
Better get back to the speaker view. Uh-oh. Well, okay. Sorry.
Did you hear me?
I did not hear you. Okay, Mary, tell me what to do.
Okay, we start on -4.
Yes, ma'am. So I'm going to start 1, 2, 3. There's my -4. Okay, I'm going to start right there.
Now, and we going to the right 9
Yes.
places.
Yes. 1, 2, 3, 4, 5, 6, 7, 8, 9. And so our answer is a +5. Perfect. Perfect. Thank you, Mary. Is there any problem with these? Anybody? This will definitely help you if you will do these number line exercises, even though you know good and well what 3 + 4 is. Do it on a number line. Do it on a number line so it starts to be pasted in your brain. Okay? Any questions on a number line? Okay, the worksheets that you have for this, you will be given this. This is the very, very beginning. They actually start you where you're supposed to. They do the loops for you and everything. Okay, so very elementary there. But look at these. Take this seriously. I promise I'm not wasting your time. Then you have another sheet that tells you, but what you're supposed to do here is tell where it started, how many loops, and what's the answer. They want you to fill that out. The next one, they just give you some problems here, and you can use this and do use this. I know you guys know these, but use the number line over and over again so you can start to make that solid in your brain, make that connection. It'll help you so much more when we get to negatives. Right, Sherry?
Yes, ma'am. It only takes 42 times to learn something.
I told Sherry when she was in my class that when we had our teacher classes, they said, now listen, students aren't going to know it the very first time you tell them. So let them relax, because it will take you 42 times telling your students 42 times, then they'll get it. So be patient, okay? And all of you guys, be patient. I can do 42 times without any problem, okay? I will repeat and repeat and repeat and repeat. Okay, this one again is going to be subtraction, so it's kind of the same thing. They let you put your answer there. You know subtraction, but then this moves into some negative numbers, so be sure and try that. And again, here is the subtraction one, where you fill out where you started and which direction you went. Of course, subtraction goes to the left. How many loops? What was the answer? Okay, so although there are a lot of pages that I sent you this time, they're all very basic. These basics are so important. Okay, now we're going to jump right into rules for adding and subtracting negatives and positives tomorrow. So get the number line stuff in your head, and then I will give you rules. Some people they just like to memorize rules. Okay, and so I will give you rules tomorrow, and you will have lots and lots of practice with negatives and positives. In the past, I've gone over that too quickly. And then when we get to that in problems, I see that that information still isn't with my students. So we're going to spend some time adding, subtracting, multiplying, and dividing negatives and positives. After that, we're going to hit fractions, yay, and decimals. Okay, lots of basics. And then from the basics, I'm pretty sure we're going to move, I'll have to look, but I think we're going to move straight into solving equations because that's the basics of all of algebra. Okay. Any questions today? I love seeing your faces this morning. Thank you for joining. And if any of you did not get the worksheets, be sure to know. If you do not have a printer or any way to get those worksheets until I get back in the classroom, let me know. I'll let Josie know, and she can print those out for you. You'll just have to go by and get them. Okay? So just text me. Everybody has my number, right?
Okay.
Everybody? Anybody not have my number?
Yes, ma'am.
Okay. Okay. So let me know if you have questions on the worksheet. Let me know if you have questions on your practice packet. Let me know if you need worksheets printed at the office. Just talk to me. I'm easy. Okay. You know I love y'all, right?
Okay.
We love you too, Miss Deborah.
Thank you. I'm done for today, unless you have any questions. Let's see what time it is. We've been on for a full hour. I'm going to stop the
Oop.
recording, but I think I'm going to leave the Zoom open while you all work, as long as you want to stay on. Okay. And I will give you credit on the attendance sheet for how long you stay on. Okay. So I will take you over to my kitchen table and I will work there while you all are working. If you have questions, holler. Okay. Okay. I'm
Thank you.
going to stop the recording now.